Hi, I'm back here with RJ Bodkin, who's part of the IRVE-3 team, and we're going to find out a little bit about that inflation system that's on IRVE-3. So, RJ, tell us a little bit about your job here.
My job is to make sure the inflatable article comes up to the correct differential pressure so that we survive that dynamic pulse on reentry and then keep us inflated through the atmosphere as the pressure comes up. And then at the end of the mission, I make sure that the tank has dumped itself so that it's safe to attempt recovery.
Okay, so when you're talking about inflating this thing, what actually are you inflating it with?
We're using nitrogen gas. The reason we're choosing nitrogen right now is it's a benign gas, pretty easy to handle, readily available. In future, we may switch gases as we develop the technology, but nitrogen's a nice, safe gas to use around people right now.
Right, right. So is it? I know I've seen one of the artifacts, so I kind of know a little bit about what it looks like. Our viewers can see it on some of the images that we have and the videos that we have. But how will this thing inflate? Will it all go at one time? Will it?
All the bladders will start to fill at the same instant, but we use what we call a soft start, where the valve comes, our control valve comes a third open, and after 30 seconds or so, then the valve comes full open, and that's to give us a chance to open out of the bag and make sure we don't kink up and pop any relief valves. And then for about 170 seconds we'll run full open, and then our control system will start metering us down until we get to our reentry state and everything closes up nice and tight.
Okay, so it's done. Can you control that from here in this mission control, or is it already pre-programmed to do that?
It's a logic controller based upon what they call an FPGA. It's basically a gate chip arrangement where it makes some pretty simple logic decisions.
Okay, all right. So it's thinking a little bit, but it's got people down here reminding it what to do.
Watching it.
Yeah. All right. So you're talking about the inflation. How much nitrogen is going to be in this thing?
We pressurize for the dynamic pulse to about 20 psi differential, which is your usual car tire will run about 32 psi gauge, which because of where we fly, differential gauge is about the same right now. So it'd be it won't be quite as much pressure as your car tire, probably about 3-4 times your standard football.
Okay, so pretty common, not a real tough to. You're not going to make it sort of pop.
No, ma'am. It's pretty stiff when you actually grab it. There's quite a bit of resistance there. Our big challenge has been the amount of gas we've got to flow to fill that amount. We had to do some pretty creative engineering to get to that end state. Okay,
all right. So how does the gas travel up to, on the rocket, up to this 280 miles?
We will top the tank off. We'll fill the tank today about 4 o'clock, and then it'll sit till Sunday morning, where we'll go out and top the tank off and close it up. It's in a spherical tank in the bottom of the RV. If you're familiar with the RV, we're down at the bottom by the nose.
Okay. And
it'll ride there up to the 280 miles, and then we've got a valve that we open based on a timeline, and then the logic takes over and brings us back.
Okay, and we're going to wrap this up because I understand they need you for a test.
Yes, ma'am.
So thank you very much for joining us, and good luck.
Thank you.
Thanks. All right, bye-bye.